Just can you guys be quiet if you are serious? I mean, we have tests next Tuesday, and like, if you want to do good, you need to just please. We have very little time left. Okay, so anyways, there will be questions sprinkled from all the 9 lessons. So there are 9 lessons. It's a big chapter unit.
Yeah.
Unit. So it will be.
Use notes for this big chapter?
What I don't get,
No.
in your midterm, you do the first to the whatever. How come the final couldn't be from where the midterm?
Okay, so
You know,
I hope you remember some of the stuff important stuff from each of the unit, right? So we did many exercises of many kinds. So let me see. Let's go from lesson to lesson and see what is important. So I'm going to go to lesson 4-1. And 4-1 was about rolling the dice and so on and so forth, and tossing the coins, right?
Yeah, was it? Oh my God, we already did that.
Yeah,
That's 299.
you already did.
That's the one with the.
That's the probability.
exponents, huh?
So we are,
How to
wait a
figure out the
minute. So
probability,
we ain't doing
right?
it from
Yeah.
You going?
from
So you
chapter.
will have some probabilities that you will be asked to evaluate.
He said
probabilities.
4-1.
For example, some questions would be very simple. Suppose you have a bag.
I like that one.
That's pretty thick.
Yeah, that's what I'm saying.
See it
I can see it. Can you? Yeah, that'll work.
Okay, so what about blue? Suppose you have a bag of marbles, right? You have 4 blue marbles and 10 yellow and 15 red, right? And what other colors we have?
Great.
Gray and 3 grey.
Oh, I thought you said black.
So, what is the probability that you put your hand randomly get a blue mark? Probability for blue.
1 out of 4.
Oh, yeah, we added one.
Yeah, so there's 18, there are 32 marbles, right? And there are 4 of them blue, so 4 out of, if you reduce it, 1/8 probability, right? Probability is always in fractions or decimals, and that's what you will find in your answers, A, B, C, and D, right?
Mr. Syed, how come you can't do it in bold? A lot of our eyes are like, ooh,
We like the other marker you were using.
yeah.
The thicker one.
So when we do the test, our answer is always going to be in the reduced form?
And then,
Okay.
or it will say answer in the reduced form,
It
and
will
there
say-
will be unreduced form too. So suppose this question was there, it says
Answer in reduced form.
reduced form, and then 432 would be there too, but 1/8 would be there too. So you have to read it. That's all, Carla. Read it.
That's all.
Like get that one wrong.
So you're trying to trick us.
Wait, what did he say?
Yeah.
That
Why I gotta
give
read
us
if I'm in
this
math?
answer.
That's okay.
It's going to give us this answer.
Do you know, like,
Answer in the reduced form. So we
do you guys remember, very important, do you guys remember fundamental counting principle?
X1
I
plus
heard it, I
X2
can't
plus-
remember.
Carla, what is fundamental?
I don't
Fun-
remember.
Saraya? Fundamental counting principle. Kaloni,
I guess she
anybody?
was wrong, right?
Just give us like a little bit and then I'll be like, oh yeah.
So if you toss 3 coins,
Oh, the
yeah, so each coin has a possibility of what? 2,
two.
head or tail. Coin 2 has possibility what? 2.
Two.
Oh, leave.
So the fundamental counting principle says the total possibilities are what? 8. So what are the possibilities? All of them are head. Remember the tree diagrams and so on. There is only one possibility. There is head, head,
Yes,
head.
yes.
So the possibility that all are head is 1/8.
Over eight.
Remember that
like that.
sofa problem? You can buy it in gray or red or yellow, or that car that you can Toyota or Honda
Yeah, with the engine.
engine hybrid and
So we should study the group problems.
yeah, whatever you did in your group work, yeah,
That's what we
definitely,
should study.
yeah.
Yeah. Okay.
Look at your
Okay, so
notes.
what was the first one? You said the first one was called what? Probability? Yeah.
This fundamental counting principle, for example.
I know, but the first
So, like in the old days, in the telephone company, before the wireless phones came in, that Jeffrey here always seems to be playing around with. We had just those landline phones, right?
Yes.
People had their homes and businesses. So there was like in US and Canada, the phone numbers are how many digits total?
10.
10 digits. There is a 3-digit area code. So this is 3 digits area code, right? Always. And then there is a 3-digit what is called exchange code. Depends on where you are. Like Victorville is 245, and like Apple Valley is 242. Desert Knolls was 242, and so on, so forth, right? Those are called exchange codes. That means where your home telephone office is. So this is the area code and exchange code, meaning where you located. So that's how many? 3. And then station code. That's a number unique to you. And how many digits that has?
4.
So 10 digits phone numbers in US and Canada. It's all one network, US and Canada. Okay, so now in the old days, but that thing is thrown out now. In the old days, there were, suppose there are no restrictions, how many telephone numbers are possible? No restrictions on the number, choosing a number. There used to be restrictions, but let's say there are no restrictions. How many numbers are possible? Telephone numbers. No, infinite?
Do you do 3 times 3 times 4?
3? No, how many area codes are possible?
You
No
got me on
restrictions
that.
with 3 digits. Just think about it. 000 is the first area code, then 001, 002,
Okay.
so on and so forth. And last one would be 99.
So there'd be 1,000.
1,000 possible area
Right,
codes.
right.
Okay. Yeah.
Huh?
How'd you get 1,000?
Because the last,
How many numbers you can make with 3 digits?
I don't know. But how did you come up with that formula? Like, did you do like multiplication?
Just think about
get it.
If you have 3 digits,
it goes up to 9.
how many different numbers are possible with 3 digits?
All the way up to
The
9.
first digit can be 0 through 9, right? So that's
Now you
10,
get it.
right?
Yeah.
Okay.
Second number can be 0 through 10. So how many are those?
That's what I was saying.
Yeah.
Is it 10 times 10 times 10?
Why didn't you say 1,000? So
I wanted to know how we got there first.
okay, 1,000 area codes are possible, right? And how many exchange codes are possible?
1,000 the same.
And how many station codes are possible?
10,000.
10,000.
Okay.
And then we have to add that together.
Add.
Multiply.
So it's 10 to the power 4, 10 to the power 10.
So is that the answer?
This 10 to the power 10,
Yeah,
that's
there's
how
10
much?
zeros.
There's 100 billion phone numbers possible. 100 billion.
But of course, it's not going to be like this on the test. It's going to be something
I
crazy.
don't even remember this. Huh?
Don't be always like that.
Yeah, but we only have so many.
I'm not going to do that.
I guess at one point we just
I struggle with this chapter.
Okay, do you guys know how to make diagrams, right? Tree diagrams.
Yeah.
I didn't like street diagrams.
Huh? Hey, can you guys be quiet? Tree diagrams. So how can you know how to make tree diagrams? So, like, what about that couple that wanted to have one boy and one girl, right? So you started with a couple.
Tree.
Then what? The first kid could be what? Kid number 1 could be a boy or a.
So all this
That's a tree diagram.
Could be a boy or a